Wide angle. Touchdown, and we're live. How's my microphone? I was having problems with it earlier. So welcome to RockSim Live. This is where we talk about RockSim software and how you can design rockets using it. My name is Tim Van Milligan, if that didn't show up on the screen. Yes, this is live. It's Friday afternoon and it's 2 p.m. Mountain Time Zone. And we have a number of people here already. We have Low Budget Bob from Buckeye, Arizona. MOB Rockets from Mesa, Arizona. Wow, we got two Arizonans. And we got Kevin's Models and More from Las Vegas, Nevada. Kevin says, Bob and Mike, I'm from Yuma originally, so the whole Arizona clan is in the house. That is cool. Sweater Dog says, video is off the audio. You say something and then 10 seconds later the video plays for what that happening. Huh. Video and audio is not synced up. Gee. Oh, it's fixed now. I didn't do anything. Awesome, cool. Yeah, so I got a monitor over here. I got the chat going, so go ahead and put in your RockSim questions. And thank you for being here on a Friday afternoon. This is what you're doing, listening to me talk about RockSim. You are so awesome. Yeah, so I got things beeping at me, so I better turn things off on my computer here. Let me throw up my desktop so that you can see my screen. I'm on the Apogee website, apogeerockets.com. If you go here, if you click on the home page, we just had a error message pop up on YouTube saying YouTube is not receiving enough video to smooth streaming. I don't know what is going on. Let me check something. I am going to try to... Am I back? Chat disconnected. Please wait. Streaming is buffering sometimes. Okay, am I going again? I hope so. I was on Wi-Fi and I switched to Ethernet, and hopefully that fixed things. So let me know if it's still going out. Okay, nothing going. My stream is coming in great, says MOB Rockets. Okay, so we're gonna assume that it's working. Rosa from Canada is here. Awesome, awesome, awesome. Okay, so as you can see on our screen, this is the Apogee website. This is where it's the home of RockSim. We also have the RockSim launch visualizer, and that's at rocksim.com. We have this banner bar here on our homepage that trying to get it to go to the beginning. There we go. So rocksim.com is our launch visualizer. That's in the cloud doing launch simulations, but we're doing the desktop version today. But this is RockSim 10 is what we're on. We are working on a RockSim 11. It's just taking so long on that, so don't look for that anytime soon. But RockSim 10 is what we're working on, and it has a lot of great features. It allows you to do a lot of cool things. And if you scroll down on our homepage and you come to this free RockSim training every week, that's where we are right now. And if you click on this image, it will take you to our archive page. Come on, there we go. And so this is the archives where we talk about, it's where the past episodes are archived. So we're on episode number 132 today. It's August 4th, 2023. So this is what we talked about last week. Okay. Describe how to distribute weight properly in a rocket. And so my question is, what do you mean by distribute the weight properly? What do you mean properly? What does that mean? And so what are you trying to achieve? If you can answer me that question, then I think I can answer your question. MOB Rocket says, I actually have a RockSim today. I am adding Apogee boosters to an Estes Leviathan. Please show how to look at stability by doing so. A Leviathan. Woo! Okay, so let's see if we can find an Estes Leviathan. Estes Leviathan rocket. Okay, so here's a rocketreviews.com, and usually rocketreviews.com has RockSim files. So that's what it looks like. It's a big rocket. It's 41 inches long, 3 inches in diameter, so that's a nice good sized rocket. And it's out of production. I am looking for, okay, so down here we have the Leviathan RockSim file. So let's click on that and see what happens. Okay, so it says download the RockSim file, Leviathan. Okay, so it opened the file and it put it in my downloads folder. So what I'm going to do is I'm going to open my downloads. Did it not open? Open downloads. Okay, downloads, Estes Leviathan. So there's the Leviathan rocket. So I'm going to go to RockSim. This is RockSim Pro. Let me get RockSim. Okay, so here's RockSim. And, okay, so I can take the Leviathan and just drag it right onto RockSim. And it's going to ask me if I want to save this old design, and I'm going to say no. So here's the Leviathan, and that looks very similar to what we just saw. Oh man, whoever did this rocket, I love him. Because what he did was he put all the colors in. So let's see if we can find out who did this and thank them. So to find out who did it, you go here to Rocket Design Attributes, and it says Estes Ventris. Click on More. No. Usually the rocket designer should be listed right there. Let's see. It doesn't say who submitted this design. But whoever did, other than having it listed as the Ventris, that's okay. So what we want to do is we want to open, I'm going to open a rocket that already has the pods, the strap-on boosters. And I showed you how to do this before. Let me go back to the Apogee website. So apogeerockets.com, and we go to the archives. And what we want to do is search on this page for something. And so you can do a Control F, or on the Macintosh, it's Command F, and it brings up a Finder window right here. And let's type in 2 instances. So I started typing 2 instances, and this is what I want. Can you do 2 instances of RockSim at the same time? And the answer is yes. And so I'm going to kind of skip this part to open up another instance of RockSim. So basically I'm going to have 2 programs open at the same time. And so to understand how to do that, go to episode number 26, and it will show you how to do that. And that's at timestamp 58 minutes and 55 seconds into the video. But for me, I have RockSim Pro open. So I am going to open File, Open, and I want to open the flying machine. Because the flying machine uses that strap-on booster pod. And I just want to copy it, because then I can copy everything all at once. I am looking for flying machine. There it is. Flying machine, open. Save my changes, nope. Okay, so here's the flying machine, and it has these pods on the outside, and I want to copy one of them, and I'm going to paste it into my other RockSim. So to do that, you go to the components, and I got the two pods. I got a port side and a starboard. So the starboard is the one on the right, port is on the left. Doesn't matter which one I grab. So I'm going to do that one and do a right click on there and do a copy. And then I'm going to go to my other one, my other version of RockSim. Where did it go? Where'd it go? Where'd it go? Here it is. And go to the design components, and then I got to pick a tube where this is attached. And I can do either that body tube, the front one, or the back one. I think I'm going to do the back one. So I'm going to select the back one and then do a right click and then get this little menu and then push paste. Okay, so it pasted it down here onto the rocket. You see that? Put it in the wrong spot though, but that's okay. At least it got me there. So I got all my pods. So the pod, if you click on this and scroll down, it's made out of a nose cone, a body tube, an engine mount, engine block, a couple of centering rings, some mass for a shock cord and streamer, and then another streamer. So let's look at this in from the base view. And so right now it's interfering with this fin. So I need to slide it 45 degrees one way or the other. So I'm going to go to the pod. I'm going to go edit the pod. And let me look at the base view again. So here's the base view. And I can go to radial position tab. And this is where it's going to rotate it. So right now it's at an angle of 180 degrees, so it's straight down. So 180 plus 45 is 120 or 225. So if I hit 225 on my keyboard, it moved it there, which is exactly where I wanted it to go. So there it is. And then if I look at it in 3D, rotate it around, so now it's no longer interfering with my fins. So far, so good. I just realized my head is like really small. Oops, wrong one. Come on, trying to grab this one. There we go. I'm clicking the wrong button. There we go. I just wanted to move that. Okay, now, so now we need to duplicate this, and I want to put one on the other side. So let me look at it from the side view. Come on, side view. Where we go? There we go. So right now, I actually put it on the port side. So now I need to add a starboard side. So I'm going to do another copy and paste. So I'm going to do a copy, and then select the body tube, and then do a paste. And you'll notice I got two port side pods, but it's identical. It's the location. It copied the location as well as all the parts. So now I need to adjust one or the other and make it into a starboard pod. So let's open this one and let's call it the starboard pod. So I can tell them apart. And let's go radial position, and we'll call it 45 degrees. Holy cow, look at that. When I moved it, some of the parts in the bottom view didn't move. That's interesting. But if I look at the side view, they're all there. Let's look at it in 3D. I think that's just some kind of remnant going on. Yeah, everything looks there. So we'll go with it. Okay, so now I've added my pods. So now back to the original question. Let me go to the original question. How do you look at stability by doing so? So I've added the pods to the rocket. So now we're going to look at stability. So when you look at stability, you should always have the rocket motors installed, because what that's going to do is it's going to move your center of gravity back. So when you're looking at stability, you're always looking at center of pressure versus center of gravity. And so if I go to a side view, right now it's showing my center of pressure right there and my center of gravity right there. Let me make those a little bit bigger. So to make these indicators a little bit bigger so you can see them, what you do is you go to the design attributes and then you go to the side view marker size, and right now they're almost 0.4 inches, so I'm going to make it 0.75 inches. And see, that just makes everything bigger so you can see them. So now I can see my center of pressure symbol a little easier. Here's my center of gravity. It's showing that this rocket is stable by a margin of 2.11. And that means that the distance that between here and here divided by the tube diameter is 2.11. And that's a fine number. Anything greater than 0 is going to work, but we typically like to have it at least 1. But we don't have the rocket motors in. When we put the rocket motors in, this rocket's going to get a lot heavier, and that center of gravity is going to move back because all the new weight is back here. So let's put motors in here. So we have the inside body tube right there. It's a 29 millimeter tube. Choose an engine. I'll just pick one and choose 10 seconds. Going weird places. Okay, so then our booster pods. Let's go. Let's see if I can find something that has a high thrust. And here's a D20. I like that. So let's make that a D20. So the delay that we choose is going to determine when the pods fall off. And I typically like to have them fall off right away. So I would choose 0 seconds delay, and you can choose it 0 by choosing custom. Plugged does not mean 0. Plugged means that there's no delay, no ejection charge. So they're going to be fixed and locked to the side of the rocket. And we want them to fall off, I assume. So you either want to choose a 0 or a positive number. You know, this rocket motor, I think the lowest it has was 4 seconds. So I can choose 4. I think that's the lowest. But you can type in a number that if you don't like that number. How would you get them to fall off in real life? That's a trick. You'd probably have to do something like modifying the motor, which is not something the NAR approves of. So we'll use a 4. Okay, so I have a Quest D20-4 in the outer pod, and I'm going to load it into the same one into the other side, so I can just hit load all. And what load all does is so the motor you have highlighted, any other engine mounts with the same diameter, it will load it in there. Because this is a 29, that's a different diameter than 18, it's not going to load it into that tube. So when I click load all, it's only going to load it into the one tube. And that worked, so that's good. Let's go look at flight events. We have a parachute in the booster, And these show us that these are the pods, and we have streamers in the pods. Yeah, so we'll just leave those alone. Leave the simulation controls alone. Starting state, we'll probably make this a 8-foot rail, which is 98 inches. We'll launch it straight up. Launch conditions, we'll have a 6-mile-an-hour wind. So when we launch it, that's what we're going to happen. Okay, so click OK. So now it loaded the motors back here. I didn't launch it. I just wanted to see where my center of gravity was. So before we had a margin of I think it was 2.1. Now it's 1.08. So it's still ahead of the center of gravity, or center pressure, which is good. This center of gravity always has to be in front of this, towards the nose. And like I said before, I'd like to have it at least 1. And this is 1.08, which is good. If it was less than 1, I'd probably still launch it. So we have 3 motors in there right now. If I look at it in 3D, come on, there we go. Let me save this design. Okay, so I saved it just in case, because we're doing heavy modifications here and I don't want to do it again. Because RockSim has been known to crash. But we don't want it to crash. Okay, so there's our rocket with the 2 strap-on boosters, and we saw that the stability looks fine. So at this point, you can launch it. So we've checked the stability. It looks good. Now, if you want to launch it, okay, we'll launch it. So I'll go back here and click on Flight Profile, and this is the RockSim Flight Profile. And so it's showing down here. When you launch it, it shows it taking off. The RockSim profile, it kind of shows you the trajectory, but it doesn't show the pods falling off. We got a really long delay. Okay, so here is the rocket sitting on the pad. Let me zoom out a little bit so I can see where this is. Oh, I remember. Last week we were launching from San Diego, and there's an island in their bay where the club launches from, and so I'm trying to scroll out so you can see the whole island. There it is right there. You know, this is San Diego. Here's SeaWorld of California, and it's called Mission Bay Park is where the launch site is. And let's zoom back in and see the rocket. There's the rocket sitting on the pad, although I don't see the pad. But let's launch it anyway. It's going to stay in the air for 48 seconds, almost 49 seconds. So when we launch it, you see the pods are sitting there right now, but at 4 seconds they should fall off, and they fell off. The rocket is still coasting upwards and then falling down. It's in the cloud of smoke. I don't think I have any wind in this simulation. All right, let's zoom out. It's going straight up, and I'm zooming out, and it's like being really finicky. Come on. Yeah, so there's my trajectory. It's just a straight line up. Must not have had any wind. So wind table, yeah, I had 0 wind. Let's give it like 6 miles an hour. And this wind is coming out of the 270 direction, which is west. So if you look at a compass, 0 degrees would be north, 90 would be east. This is the direction the wind is coming from. From the south would be 180, and 270 means coming out of the west. Let's also change some things. So those pods, they fell off way too late. So let's make them fall off earlier. Let's make one fall off at 0 seconds and the other one falling off at 1 second. And that will make it a little bit more colorful. And let's do that flight profile again. So we're going to launch it again. And it's running the simulation. And check here and see if we got other questions. Oops. I came on the wrong screen. When I moved my cursor over there, I thought I was over there. Okay, so there's the rocket again. This is going to be a little shorter flight, probably because we're arcing into the wind. So the rocket takes off, it spun around, those pods fell off right away. Boom! And the rocket coasted. But let me pause it. Right. Oops, I stopped it. Let me pause it. And let me zoom out. Let me change views here. Let's look at it from a trajectory view so you can kind of see. So the rocket started right there. The smoke starts right here, but it starts there because the wind had already blown it this way. If you look at the compass, the black triangle, that points to the north. So I'll try to make that north. Let me tilt this a little bit. So the rocket, it took off from right there where my cursor is. It went up, and you see this little green line? That is one of the pods falling off, and then this one, this other one, is the other pod falling off, and then the main part of the rocket is way up here at the top. And so then it arcs over, and I lost it, so I got to back out a little bit. It's going pretty high. We're at Apogee right there. Apogee is, a little over 1,200 feet. And then we can scroll through the time and see where the rocket comes down. And it's going to be under this image. I could turn that off. So it landed in this nice sandy area right there. The other pods landed one right there, and then the main rocket landed right there. So that's a beautiful flight, actually. I like it. All right, so that is pods and how to determine if they're making your rocket stable or unstable. Tony Ermit says, I flew my so long twice, lost it in the sky when flying on 2 F-15 motors, but was able to find it on the ground due to the orange streamers. That's good. Sweater Dog says, how do you make a thin-walled tube thicker in real life? I think we talked about this last week. Oops, where'd my screen go? I'm here in the archives. We talked about it last week. Did we talk about that last week? How to make a thin-walled tube thicker. Yeah, so we did talk about that. And basically what we said was you're going to need to take paper and wind it around the tube so you can thicken it up on the outside. You're probably gonna have to do it on the outside because it's really hard to add additional paper on the inside to make it thicker. Cat Servant said, did you see my question at the top of the chat? Let me see. Cat Servant. No, I do not see your question at the top of the chat. So, Cat Servant, if you can put in your question again, I'll try to answer it. It's at the very top where he asks about the Super Big Bertha. I don't remember asking about the Super Big Bertha. Stark03 says, I put a camera on my Fusion 3 SBR rocket and it spun like crazy. All other rockets with the camera added spin also. Camera is blah, blah, blah. So he gives a size. So he's asking, does that cause a rocket to spin? And the answer is yes. Let's see if I can get one to spin. See, and you're not going to see it spin in RockSim, but it's possible that you'll see it spin in RockSim Pro. So if you're in RockSim Pro or the Launch Visualizer online, let me see. So let me open up a new browser window here. Okay, so I got Chrome, and I go to rocksim.com, and it's loading. and log in. So you need an account to do this. I'm going to use my account, and you can use a free account, but you got to have an account because you need to have a rocket in there. And what I'm looking for is the Estes Astrocam because I know it has a camera on it. There we go, Estes Astrocam. So select that. This one I uploaded myself, so it's in my personal upload folder. To upload a design, you click on the button right here, and then you find it on your computer and upload it. And if you can't find an Estes Astrocam, you can get one from the Apogee website. So if I go to Apogee Rockets, and if I type in Astrocam here, Astrocam, there it is right there. And then it brings you to the Astrocam rocket, and that's what it looks like in real life. You can see it's got this camera on it. And if I scroll down to here where it says RockSim file and I click on it, it's going to take me to the bottom of the page where the RockSim file is located. It's like a mile down the page. And then you can click on here and this will download the RockSim file. And then once you download it onto your computer, then you have to re-upload it into the cloud. Now, if you don't want to do that, another way to get to it is, do I have it here? No, I don't. Sometimes I put them on here. I don't. This rocket doesn't have it. Sometimes I have the launch visualizer on the page itself, but this one I don't. So here's the Estes Astrocam, and you can see I put a camera hood on the top. And the camera hood, there's not a button in RockSim to add a camera hood, but you can simulate it by using a fin. And that's what I did right there. Instead of making a fin down here at the bottom of the rocket, I put it at the nose. And I made it thick like you would if it was a camera. So I've got a fin up there. And if we launch this, and let me, we'll be at the same launch site. And if I select the motor, choose an engine, and what I'm looking for this time, I want a long burn motor. So I got a Aerotech C 3.4. That's 2.6 seconds burn time. I'm looking at this column right there. If I click on it, I can sort it by list, and if I click it again, I can see what different motors. So I got the longest one is this Aerotech D 2.3, which I think is a reload motor. And I think this C 3.4 is also a reload. The longest single-use motor is a C5, so we'll use that. And we'll use a custom delay, and I'm going to make it 5 seconds. Just for grins, just so it'll coast upwards a little bit. And then click OK. So we have the engine loaded. Overhang, let me make that 0.5 inches. .5, hit tab. Okay, and then the flight events, we have a parachute in there, deploying at maximum ejection delay. And then we're going to click the launch button, which is below my face here on your computer. There it is right there. Click that button. So we'll click there. And it's going to say it's going to use 8 credits, and we'll say simulate. And what it's going to load the launch visualizer again. And what we're looking for is seeing if the rocket spins as it goes up. So you got to watch real close. Okay, it is spinning. It did spin. I don't know if you caught it. So let's turn off the smoke. Let's turn that off so you can see it. Okay, let's back that up. You see the camera hood right there? So it came off. It almost did like almost 1 revolution. But in real life, it might do a few more. Yeah, so you can see it spin. That's what happened. This is called, it's called pitch roll coupling. Let me go to a wide angle. So here on the screen, so here's a rocket, and so imagine your fin or your camera hood up near the top of the rocket, somewhere in this area. So what happens is that puts drag on one side of the rocket, and that drag is going to cause the rocket to pitch because you got more drag on one side. It's kind of just like pulling it off to the side, pulls it down, and then if you look at the fins on the bottom, and these two fins down here, if the rocket is going this way, these are now at an angle of attack. And so it's usually one of the fins is at an angle of attack, and that one fin will cause lift, and the lift causes it to rotate. So you have pitch roll coupling. Sometimes it's called yaw roll coupling. It's just, but it always happens is once it starts pitching, the fins create lift down here at the bottom, and that causes it to roll. You might be able to even it out by putting another fin on the opposite side or another camera hood on the opposite side. That can dampen it. You can also make, a lot of people will put heavy weights on the tips of the fins. And what that does is it increases the inertia, the rolling moment of inertia. So it doesn't want to roll very fast. So once it starts, it's not going to go really fast. It'll roll slower. It's still going to roll, but it's going to be slower, and it might be less vertigo in your camera image. So, come on, let's close you. Go back to here. All right, let's go here. Okay, Kevin, my phone chat doesn't. Oh boy, all of a sudden my thing jumped. There's so many comments. You guys are like talking amongst yourselves. What is this thing to do? I gotta scroll up, man. There's so many comments. Okay, Sweater Dog says, a question for the future me. Does RockSim support importing liquid rockets? It's a good question. What RockSim needs is a thrust curve. And then the actual type of propellant, it doesn't care. So the answer is yes. But you have to have a thrust curve of the rocket motor. And so if you're back here in the our archives again, you can type in adding motors. Okay, so add motor. So episode number 121, how to add motors to your RockSim. So there's a two-step process. One of them is to create the thrust curve. Let's see if we have thrust curve. Thrust curve. Okay, so creating a thrust curve from rocket engine data using engine edit. So that's your first step. So there's a program that comes bundled with RockSim called engine edit. So here's RockSim, and if you go onto your computer, if I go to the launch pad and I type in engine edit, I got several different versions here. So this is from RockSim version 10 point something. This is the latest one. This is the one from RockSim Pro. Basically, they're all the same because the engine edit, it doesn't change. We don't really add features to it. And so this is what it looks like when you open it up. And you're going to click on Add New Engine. You're going to tell it how long your liquid rocket engine burns, you know, it might be, you know, 30 seconds and have a peak thrust of, you know, 100 newtons. You click OK, and then it draws this grid right here, and then you just start clicking on the points to draw your thrust curve, and then you're going to enter in some other physical parameters of your rocket engine. But when you load it into RockSim, so that's the first part. Then you create the engine, and that's what episode number 121 showed. And then you import it into RockSim. And when you import it, it's still going to look like this back here at the back of the rocket. It's going to look like a solid propellant motor that can come in and out, but it's just a liquid engine. Even though it might stay stationary in the rocket, it will still be a liquid engine in there. And yes, it will work. That's the short answer. But there's a lot involved. You got to make your thrust curve, and then you got to load it into RockSim. And both of those were covered, and I think I pointed at them. A question for, okay, so sort of, okay. Kevin is actually looking into trackers. You have to make all the tanks and engines mass object. Terry is answering the question of, can you put in a liquid rocket engine? And he's talking about the tanks and the engine mass as mass objects. Yes, or you can also, you know, when you're going to be putting a mass here as well. You know, you have an initial mass and your propellant mass, and so you subtract your propellant, you know, your liquid part from the initial mass, and that's the excess. You know, that's your hardware. So it does account for it already. So you might not have to add it as separate mass objects. Depends on how you do it. The simple way is you don't have to, but you could if you wanted. Low budget Bobs. I'm building an Aspire from Apogee and bought the Avbay, seeing as how it will go 5,000 plus feet. I want to find it again, so I'm getting a tracker. Yep, that's good. It froze. Hi, launch it now. It keeps lagging. I mean, so my computer, it's got to be something in the stream, and I don't know why. Our internet here is usually pretty good. Terry Wheelock says it's Chinese hackers. Micah Peterson says, what is good glue to use for engine holders? Because on my homemade rocket that I made, I used hot glue for the engine holder. Micah, hot glue is not used in model rocketry. Don't use it. The glue you use in rocketry depends. You know what? I don't think you saw my screen. I forgot to switch back. I'm sorry. The glue you use in rocketry depends on what you're gluing together. So if you're making an engine holder, so if it's paper and paper, so a paper ring on a paper tube, use white glue or wood glue. That's the strongest. If you want it to, if you want something that cures fast, you can use super glue. Super glue doesn't quite penetrate the paper like wood glue does because the water gets into all the little fibers, but it's probably strong enough. You can also use epoxy. Again, it's going to be about the same strength as the super glue. So those would be the three glues. Wood glue, which we use a lot, epoxy, or super glue. So those are the glues you'd use. Low Budget Bob says, I wondered the same thing myself. I need to do the sim on and find out. The tracker I want to use is heavier than what they show to use. So he's talking about the Apogee Aspire, and he's putting a tracker in it. So let's open up, save that. File, open, and I'm looking for an Aspire design. Apogee Apprentice Aspire. Here we go. Aspire rocket. Okay, so here's the Apogee Aspire, and this thing like really goes a long way up. So if you were going to run a sim and with a new tracker in it, so we're looking at a side view, and I got different mass objects in here. So a tracker, you're probably going to add it as a mass object. So if I go to the design components, I got something here that weighs 2.5 grams, which is pretty small. I got a shock cord here, streamer right there. So first you're going to, the quick and dirty way is you're going to weigh all your new components that are going to go into the Aspire. And this probably includes your eBay plus your electronics and battery. And the quick and dirty way is just weigh all that and then just throw it in the design that we have shown here. And so I'm going to put it into the forward tube, and I'm going to call it a mass object. And then I got to say, this always looks in the database first, so cancel out of that. And right now it's putting the mass object at the nose, and I want to put it all the way at the back right there. This is going to be my eBay right there. It's going to be a little longer on the inside, but all the mass of it, where it balances, is going to be about the middle. And then you just tell it how much mass it is. So I'm going to go to the Apogee website, and I'm going to look for the eBay. We got the eBay. That's a 38 millimeter. I don't want that one, but I want to go there. And I want to go to the 29 millimeter eBay. 29 millimeter eBay kit. And this eBay weighs 26 grams. So I'm going to get a calculator here. Oops, not Slack. You want a calculator. There's a calculator. So 26 grams. Put that into storage. And we'll go plus. And now we need a tracker. GPS tracker. The simple GPS. GPS trackers are not cheap, but if you want to get it back, where's the weight of my tracker? There we go. Specifications, transmitter. This is the part that goes inside of your rocket, and it weighs 15 grams. So we're going to do plus 15 grams. That's 41 grams, and now we got to add a battery. And we'll probably go with a single cell LiPo. 120 milliamp hours. So this is a little tiny one. That will probably work. You probably won't be able to power it forever, but it'll probably power it for long enough to get your rocket back. And that weighs 3.4 grams. So we're going to go plus 3.4 grams equals about 44 grams. So if I go back to RockSim, and my mass of my tracker plus my battery, I was just thinking, am I going to do dual deployment on this? I'm going to say no. I'm still going to use the streamer. The streamer is going to make it fall fast. So I'll just throw 45 grams in there, and we'll call this the tracker and eBay. Click OK. And I don't know what motor he said he was using, but we'll see what motor we can put in there. So I put it right there. And let's load a motor. And we want to choose something that has a really long burn. So I'm going to go to the long burn. Oh, I don't want to use an H. Do I want to use a G? No, no, no. I want something that's single use. And I mean, why is it not showing our Apogee F10? F25 has a burn time of 2.69 seconds. Ignition, and we want this to be a 9-second delay. And let's launch it. I'm still in RockSim Pro, but it'd be the same thing in RockSim. So it's going to go to almost 4,000 feet. I could see that right there. So we lost. Well, I don't know. I don't know what. There's another F25 up here, but I don't know what the conditions were on that one. And if I launch it, click that. Rocket takes off, goes nice and straight. It's going to go really high. So that's the quick and dirty way to run simulations. Oh, look, Kevin's Models and More. He says, Bob and Mike, my tracker with battery weighs 44 grams. I should have read that. But I confirmed it. When I launched it, it failed because the ejection charge was fired and the engine holder broke because the glue started melting. Yes, Micah, that is why we don't use hot melt glue. Hot melt glue will melt when it gets reheated. That's why we wanted something that stays solid no matter what the temperature is. Kevin's Models and More, it fits into a BT20 tightly. Wow, that's a small tracker. Terry Wheelock says, yes, use white glue, that's good. I did use epoxy for anything above a D engine. Yes, I know it's overkill, but I like having indestructible rockets. For C engines only, I wouldn't use hot glue for anything in rocketry. There's places for it, but it's only where you want something that you can remove later. Micah Peter says, Apogee components should make a rocket that lands like SpaceX Scout rocket. We do have a rocket that lands like a SpaceX rocket. It's not like you'd like. It doesn't have engines burning, but it's called a mega lander. So if you go to the Apogee website and you go here to the top and you type in mega lander, there it is right there. So it's called the Starlift Mega Lander. And let's see if we can get some pictures for you to show. So there's where it looks like. There's what it looks like on the launch pad. Here's where somebody built one and is photographing it. That's when it takes off. And you get a parachute. That's what it looks like on the pad. Another takeoff. Takeoff. Okay, so there it is. So this is the rocket coming down. It comes down in two parts. The top part, I call the penetrator, has its own parachute, and it comes down nose first. And then the tail section, you can see the legs, they splay really far out so that the rocket will land vertically. And it's always cool to see the rocket stick the landing. You can see how big it is. It's a nice 2.6-inch diameter. I thought I had a picture of the rocket. There it is. It lands upright. So that's what it kind of looks like once it lands. Yeah, so very cool. We've got a lot of comments here. Laminating. You have to manufacture the filter. It was set to Aerotech instead of all. I'm a low budget. Bob says I'm doing 3 fins and a plan on using the F10. Terry Wheelock says mega lander, yeah. Will 3D printer guy says, will Apogee ever stock L3 motors? I am from the UK, but it's just one of those random questions I think of. Um, L3 motors are so expensive that having them sit around and not being purchased, yeah, we'd have to order them in advance. So a customer would say, "Hey, I'm gonna do my L3 in the future. Can you get me a motor?" We could order it, and then it takes about 5 months to get here. And then we could ship it out. And that's the downside, is we don't have the ability to buy those big motors and store them for long periods of time, because it's just so much money sitting around. And the bigger the motor, the fewer we sell. So, we sell a lot of A's, B's, and C's, and D's, and E's. But then as you start going up and up and up, the motors get more expensive, and then they sit and collect dust for longer periods of time. So we don't order a lot of them. Yeah. So there was a lot of questions. You guys have been at it today, putting me on my toes, and which is fine. Lots of good questions. We got to see what RockSim could do. We're at the top of the hour, so this is a good time to stop. We will be back next week. I will not be here, but Michelle will be here. My daughter is going off to college, and so I get to load her up and haul her away. So she's gonna be studying biomedical engineering. So she's gonna be an engineer. She wants to be an engineer. Her goal is to design spacesuits, and so that's gonna be, the more astronauts we put out there, the more spacesuits we're gonna need. I didn't know this, but all the spacesuits that SpaceX flies are all custom made. So, yeah, they have to fit the astronaut. I saw a video on that on YouTube. So that's very, very, very cool. Terry Wheelock says, "Go UNT, University of North Texas." Yep. Thank you, Terry. She's working here today. She's trying to earn a little bit of money to go to college. So it was good to see her at work today. All right, so we're gonna end this in 5, 4, 3, 2, 1. Go out and launch something.